Another example would be a web developer writing a web application in PHP or some other high-level language. That developer doesn't need to understand the details of copper or fiber cabling which reside at layer 1 in the OSI model. The layers are separated and are independent of one another, so the areas of concern and responsibility are split, which makes things a lot less complex. When saving a file in Microsoft Word, as an example, to the local hard drive or to a remote network share, the developer doesn't need to understand the finer details of iSCSI or storage area networks, SANs, or some other low-level disk management software. The developer doesn't need to be concerned about whether a local hard drive is used, which could be IDE or SCSI, on the local machine, or a remote network drive using some type of attached storage. From the viewpoint of the developer, his application is only talking to the layer directly below the layer he's working at. So the operating system, for example, such as Microsoft Windows or Mac OS, will hide or abstract the developer from the lower layers, thus making development a lot easier. Now, as I've mentioned, from a troubleshooting point of view, the OSI model is going to make your life a lot easier, especially when discussing network issues with other engineers. We'll be able to determine, as an example, if a problem is a layer 1 problem, so a cable is unplugged, or it's a layer 3 issue. Let's say OSPF is not advertising routes. Or if it's a layer 7 issue, your FTP service may have stopped, or there may be a bug in the application. Once I go through each of the layers, you'll hopefully have a good understanding of each of those layers, what they do, and hopefully it'll help you with troubleshooting. The OSI model has also helped accelerate development of new applications and technologies. In the last few years, there's been massive development in technologies that rely on networks. Think of the fact that not many years ago, sites such as Twitter, Facebook, LinkedIn, and other social media sites didn't exist. Today, developers, for example, working on Facebook, don't need to understand what an ISP or Internet Service Provider is doing in the UK. All they concentrate on is the development of their website, and the ISP will route traffic to those websites using protocols such as BGP or OSPF. So it's not necessary for an application developer to understand the details of networking. By the same token, a network engineer troubleshooting a network doesn't have to understand how Facebook works. In other words, he doesn't need to understand the details of PHP, programming, or Apache services. Network engineers can concentrate on network protocols rather than programming languages. Now that may change, and it probably will do with technologies such as software-defined networking or SDN. And additionally, you may be the only person who does all the network and server support in your organization. So you have to understand all the layers. But that being said, it still helps simplify teaching and learning as well as troubleshooting in the real world. Please ensure that you have a good understanding of the OSI model because it'll give you a much better understanding of networking. That's what these videos are hopefully going to give you. We as network engineers will use names and numbers interchangeably, so we'll often talk about layer 2 or data link layer, or layer 3 or the network layer. So remember your numbers and your layers. Layer 1 is physical, 2 is data link, 3 is network, 4 is transport, 5 is session, 6 is presentation, and 7 is application. Remember both the name and the number. Now in the past, there used to be a major split of concentration in the OSI model. The top 3 layers were the focus of developers and server administrators. The lower 4 layers were the domain of the network engineer. These days, because of the growth of technology such as VMware, this divide is blurring away. This divide is often not there, and these roles are blurred. Often today, network engineers need to troubleshoot servers, and server administrators need to troubleshoot virtual switches within a VMware server. But traditionally, developers focused on the development of applications, such as Firefox or Chrome, which resides at the application layer. Developers would need to understand how to present data in specific formats. Server administrators would have to understand operating systems and how they manage sessions and interact with applications, and thus they tended to concentrate their effort on the top 3 layers. Network engineers concentrate in most cases on the lower 4 layers of the OSI model, and hence that is the focus of this course. We're going to concentrate mainly on the transport, network, data link, and physical layers. In other words, layers 1, 2, 3, and 4. It's a well-known joke in networking circles that developers will blame the network when applications are running slow. In some cases, developers don't understand networking, and that's perhaps a byproduct of the OSI model. They don't need to understand networking because of the split roles and the split layers. Developers may blame the network for performance of their applications, whereas in actual fact, the reason could be something else, such as the server being overloaded, or a memory leak because of bad code in their development. But in brief, network engineers concentrate on the lower layers, server administrators tend to concentrate on the upper layers, even though those lines are now blurring. So I'm going to start off with a brief overview of layer 7, 6, and 5, and then we'll look at the transport, network, data link, and physical layers in a lot more detail.